I'm going to be showing you an introduction to quadratics. It's important, first of all, to know what do we mean by a quadratic. A quadratic is something that's a polynomial of degree 2. That means the highest exponent is 2. It can't be any higher than that. The graph looks like a parabola. So I'll show you an actual graph. So maybe just something like this. That's a parabola. See, it looks kind of happy. It can also be opening downwards. So we say it's sad. That's actually why I put this one. This one just made me laugh because look, if you look at this, I don't know, is that an ostrich? Look, it looks like a parabola, his beak right here. So I was thinking about parabolas when I saw this. Maybe it's just me being crazy, but there you go. It also just makes me laugh. So the general form of a quadratic. Good news, you don't have to memorize this. This is in your formula booklet. It goes like this. We'll make it a function, so it'll be f of x. It could just as easily be called a y, right? It's going to be equal to, now the general form means we set little variables to mean the numbers. So we have ax squared, that's going to be a coefficient in front of the x squared, plus bx plus c. This is how we're going to do it here. Okay, this is something that's on your formula booklet, so you don't have to memorize it, but it is important. Okay, so formula booklet. This is the generic form. Basically, as long as we just say what a is, what's b, what's c, those are just, real numbers, some kind of real numbers. But there is one stipulation. I don't know if you can see it. There's one thing that we can't allow. I can make b and c anything I want, positive or negative. Nice numbers, integers, really ugly, irrational numbers, doesn't matter. I can make this pi, doesn't matter. There's something with a. Do you know what it is? A cannot be 0. Why not? Well, if I made a 0, do you notice then that would make this whole thing here cancel out? Do you see you get bx plus c? That would be a straight line. That would just be a straight line graph. So that's actually why we can't let a be 0. So as long as a isn't 0, you could have b 0, you could have c 0, but you need an x squared. It's got to be degree 2. It can't be cubed. Then it's actually called a cubic. I mean, it can. It's just that it's not a quadratic anymore. Then it's a cubic. So we have different names for them. But quadratics are ones with x squareds going on somewhere. So a little pro tip, watch out for things be in a different order. So for example, what if I gave you something like, I don't know, f of x equals, let me just make up something like 2 plus 3x squared minus 5x. This is still a quadratic. It's the same thing, by the way, as saying, I can just rewrite it in the same order. So it's 3x squared minus 5x plus 2. Keep in mind, we write them in this order, but they don't have to be in this order. The key thing to know is, in this particular example, whether you wrote it like this or like this in descending orders of x, the reason we write it like this, so we always know a is absolutely going to be 3. B is for sure -5, and C is always 2, whether you wrote it like this or like this. A is the one in front of the x squared, always. So that's just why, just remember that, because even if you looked at it here, you'd be like, oh, A is the first one, this is B, this is C. Nope. A is the one in front of the x squared. B is the one in front of the x, and C is the one by itself. So that's the important part, okay? Now finding the y-intercept is actually pretty easy. Remember what the y-intercept is? That's when I'll just say set x equal to 0. That's the y-intercept. Let's see if we can find it here. So, can we do that? Let's see if we can do it. F of 0 then. I want to know what happens when I put in x equals 0. What do I get? Well, I'm going to have a times 0 squared plus b times 0 plus c. And do you see what happens? These are here cancel out. So we know that f of 0 is just going to be c. So the y-intercept is just this c term. So that's actually kind of nice to know. It's not really need to know, but it's nice to know. I think that's a neat one to see. So the y-intercept is actually just always c. Okay, that's important. I wanted to show you with a graph because we can do some different things with it. Watch. This one right here, we know something about the a term. We actually know that a is greater than 0. A is positive here. And here we know that a is less than 0. It's negative. So if the first term, or the term in front of the x squared, is positive, it's going to open upwards. If it's negative, it's going to open downwards. So we know if it's going to be a happy or a sad parabola. What's nice, depending on the calculator you use, with the TI Inspire, you can do something really cool. Watch. Now I'm going to make a mistake on purpose just to show you something. Okay, so I'm going to write it like this. Right now it's not going to work out right. But I'm going to try to write with just A, B's, and C's. The TI Inspire is interesting for that. You have to put the times here. It doesn't know what AX squared is, but it has to be A times X and B times X. If I do that, watch, it asks me, do you want a slider for A, B, and C? Yeah. Let's mess around with numbers now. So now I've got things at 1, 1, and 1. So if I made this 1, 1, and 1, it would look like this. Watch carefully what happens then. I'll just place it here. What if I play with just A? Watch. I'll make A negative. Remember I said it's going to open downwards? Look, it opens downwards always. If I make A positive, look, it opens upwards and it's steeper. What if I make A 0? Hey, it's a straight line. Why? Because this right here canceled out, which means we just got a BX plus C. It looks like a straight line. So that sort of explains that one. Let's look at C next. C is just going to be shifting this whole thing up and down. Let's see what happens here. Look. See, as I play around with C, look, it just goes up and down. That's all C does. Now, B is a bit weirder. It does this weird thing like this. Watch, it sort of does something a little bit strange here. B is not as simple. B doesn't really tell you so much. I mean, B combined with A tells you something. For example, it can tell you about the axis of symmetry. And A's and B's and C's can tell you where the zeros will be. So B is still important, but geometrically speaking, it's not so simple to explain what it does. It sort of makes it hop around this point right here where it crosses the where the y-intercept is. It sort of, do you notice it sort of makes it bounce around like that? So it's not quite as simple to explain. But there we go. We've got everything we need. Let's keep going. We've got an axis of symmetry. So let's just assume we had a positive one. Let's just assume I went something like that. Actually, no, I'll make it anything I want. I'll make it like this maybe. There we go, like that. So there exists an axis of symmetry where this whole thing right here is sort of the same, left or right side. Right? That'll be this. This right here is where the vertex is. So here is what we call the vertex, which is the maximum value. Right? It's the maximum it reaches. But we also have this thing right here. That's the important one. That's the axis of symmetry. This is this line across which the graph is the same left and right side of it. So if you look at this, it seems to be related to this maximum point, this vertex. So you notice this is really important. The vertex is actually is located on the axis of symmetry. That's an important thing. Maybe I'll write it right here actually. I'll say pro tip. Actually, you know what? I'll type it out. I hadn't actually thought about doing that, but I realized I should. So I'm going to say pro tip. Oops, let's see if I can type here. That's actually important. Vertex is at the axis of symmetry. Okay, there we go. So we'll see. So that right there is going to be an important one. I'll just press enter here and I'll put it down somewhere. Maybe there. There we go. So that's going to be important. And what can we do with this? Well, we have an equation for the axis of symmetry. The formula booklet gives us this as well, which is kind of nice. So the axis of symmetry is, notice, it's located. Remember, if we define something as A's and B's and C's, axis of symmetry is this. I'll say axis of symmetry. And it's going to be, we just get the x value for it. So it tells us x equals minus b over 2a. This is on your formula booklet. You don't have to memorize it, but boy, oh boy, is it important. So if you know what a is, you know what b is, then you can know what to do. This is on your formula booklet. But do you see why I said it was important? Because maybe they don't just ask you what's the axis of symmetry, but if you asked to know about something about the vertex, that's your key. Your vertex is at the axis of symmetry. In other words, this is the x value of your vertex. So this right here is actually, that's the x value of it. So let's see if we can do this. So there's a number of ways of doing it. If you know about transformations, you could go a little bit quicker. I'm going to show you without knowing about transformations. I'm just going to graph it. Okay, so I'm just going to show you how to just graph it. Maybe we'll do a sketch of it actually first. Maybe I'll need that. So I'll just do a quick sketch. I need some x and y axes here. And actually, I will use what I know about transformations first, but I'll show you how to do it with a graph. So in later videos, I'll show you about transformations. This looks just like an x squared graph that's been shifted down by 1 and to the right by 2. So I know that I'm going to take, in my mind, I'm going to take an x squared graph, which looks like this. I'm going to move it to the right by 2. This is 1, 2 here. I'm going to move it down by 1. And that's going to be my location of my vertex. I know it opens upwards because A is positive. So it's going to be something like this. I mean, I'm not getting the exact points right. I don't know exactly where the zeros are. I actually don't care. I could find them if I wanted to. But if I want the axis of symmetry, all I need to know is, what's this? Well, I know it. The axis of symmetry then is related to the vertex, remember? So if I know the vertex, then I know the axis of symmetry is that x equals 2. That was one way to have done it. Now, I could have done it mathematically by actually opening it up. So I'll say it that way, right? I could say, or I could expand this first. I'll just show you a few ways you could have done it, right? I'll expand this first. So if I do this right here, I could have actually written this as y equals, let's say, x minus 2 times x minus 2 minus 1. All right, I'll expand this. So x times x is x squared, minus 2x is minus 4x, and minus 2 times minus 2 is plus 4. Don't forget about the minus 1 there. So I have y equals, let's see, I've got x squared minus 4x, and I've got 4 minus 1, which is plus 3. Why did I bother doing all this? Because now I know what a is. A is 1. It's a number in front of the x squared. I know that b is minus 4. It's a number in front of the x. I know that c is 3. Now, why is that important? Because now I can take the equation for the axis of symmetry. Look, I know that the axis of symmetry is x equals minus b over 2a. Right? I'm going to use that one here. So if I do that, then I'll just put in the numbers. So that means I have x equals minus b. Well, that's minus 4. All out over 2 times 1, which is just 2. Well, that gives me a plus, right? So it's 4 over 2. So I can say x equals 2. Ta-da! It's the same. I could have also done it with a graph, just so you know. Just trying to show you lots of different ways of seeing the same thing. So I could put in brackets here. It's x minus 2 squared. So I'll put that in brackets. X minus 2. I need that whole thing squared. All that thing minus 1 then. Look, it looks like this. And my axis of symmetry is right at the vertex. I could just do trace, for example, if I wanted to do that. Now I'll just go along. You'll see it'll tell me my vertex. I'll say, that's the minimum. Well, that's at x equals 2. That's how I know it. So there's a bunch of ways of doing it. Now, with quadratics, we also need to know about zeros or roots or solutions. Remember what x-intercepts are? They're where it crosses the x-axis. So let's say I had something like, I don't know, something like this. Some quadratic that opens upwards. There's 2 places where it crosses the x-axis, right? In this case, there's one here and there's one here. Okay, so this is an x-intercept, so is this. These are the key ones we're looking for here. So we did it on a calculator, that's what we'd be looking for. And so much of what we're going to be doing, this is going to be the key here. We're going to be trying to find what happens, or how do we actually find these zeros. That's a big part of what we do in this course, strangely enough. And that's because they become very important with modeling, but also just with generic math. So if you're on the TI Inspire, well, first you got to graph it. Then you want to go to menu and analyze and find the zeros. That's how you can do it. You can ask your calculator for those zeros. Look, I could have done it right here on that example. If I want it right here, I could go menu, analyze, find the zeros. And I'd say, well, here's one of them. So I'll go like this. I'll guess, look, it's at +1. And I can do the other one. Or you could do it by just doing trace. I said, as I just do trace, at least on the TI Inspire, as you do trace, it just hops to the next one. You notice it said it was a 0. You see it said it in yellow there? So that's x equals 3. So that's one easy way with a calculator. If you use a TI-84, it doesn't quite do that. The trace function doesn't work as well. I think you should graph it and do find the zero. So you can press calc. It's along the top. It's kind of bluish. At least with most of them, it's blue. You do second and do that little button there. Get your calc and you choose zeros, and it's the same idea. You have another app, though. You have an app called Poly Simultaneous Equations 2. You can also do that as well. That's if you use the TI-84. So just so you know, there's lots of ways of doing them. It depends on your calculators, for example, but it's easy to do it on a calculator. Now, you could have done it by hand as well. We have this, sorry, not by hand. You can do it on a calculator with a TI Inspire. We have this polynomial tools. That's if we go to menu and algebra and do roots of a polynomial. So we could also do it that way. Watch, I'll show you here. So I could do a new calculator page. And I could press menu, go to algebra, and I could do polynomial tools, find the roots. This tells me like what's the degree of the polynomial? It's degree 2. Great. You say what's A, what's B, what's C? Watch, so if I say A is 2, let's just say, I say B is 3, and I say C is, I don't know, minus 2, let's just say. All right, so if it goes 2x squared plus 3x minus 2, I say okay, and I press enter. It'll tell me my two roots. Notice it says one is minus 2, one is 1/2. Those are the two different values where it's going to cross. So on a calculator, super easy. What happens when you don't have a calculator for it? What if you have to do it by hand? Well, then it's much more involved. And I've got videos that I'm going to show you where I show you how to do it with factoring by completing the square. I'm going to show you how to complete the square to generate this thing called the quadratic equation. We're going to use that. We're going to do discriminants. And then maybe then you feel like this. I don't know if you ever felt like this, right? You find the vertex and the x-intercept, but you can't find the y-intercept. They're making a joke because the y-intercept is actually the only one that's easy to find. The vertex is more involved. The x-intercept is more involved. The y-intercept is actually the easier one. So I've got a bunch of videos coming up that are going to show you how to do all these steps. But the key thing is quadratics will look like this, and we define them with A's and B's and C's. And given those values, we can do all sorts of things with them.